Hi, this is Esteban Sanchez from Gareth. One of the most popular questions we're always being asked from customers is, how do we measure our software? The answer to that question is, there are many different approaches. Lines of code, use cases, function points, story points, just to name some of the most popular approaches nowadays. In this video, I'm going to provide a quick introduction to function points. I'm going to show you what function points are, what are the different pieces or elementary processes within function points. And finally, I'll show you what you can do once you have a function point count. I hope you enjoy the video. Okay, so let's start by defining what function points are. Function points are basically a unit of measurement. Yes, just like you can use pounds to measure weight, miles to express distance, or Fahrenheit degrees to report temperature. You can use function points to measure and express the size of your software applications. In essence, how big an application is in terms of functional user requirements. Function points are also independent of programming languages and technologies used for development. So it doesn't really matter if the code was written in .NET or Java. It is not relevant if your application runs on Android or iOS. Just like pounds don't really care if you're measuring a cat or an elephant or a truck. Function points are going to be completely independent of technologies, platforms, and programming languages used for development. Function points are also an international standard for software functional size since 2009. Function points were first introduced in the mid-70s. Back then, a gentleman by the name of Alan Albrecht was presented with the task of finding new ways to measure application development productivity. He came up with the first version of function points. A bit later, in 1979, Mr. Albrecht published his paper titled Measuring Application Development Productivity at a software conference in California, and this was the first exposure of function points to the international software community. In 1984, the International Function Points Users Group was born. IFPUC is a non-for-profit organization dedicated to maintain the function points standards, and it also provides training and certification for the function points community. Finally, in 2009, IFPUC function points became an international standard for software functional size. Okay, so now that we understand what function points are, let's talk about what we are measuring with function points. Any type of software development project includes three types of requirements. First of all, we have project requirements and constraints. These are things that deal with project milestones and budgets, project management standards, dependencies with other projects, resources, and staffing. Non-functional requirements such as quality constraints, reliability requirements, usability, performance of the system, and security. And finally, we have the functional user requirements. These are requirements that describe what the application should do in terms of data transfer and data transformation, storage, data processing, retrieval and presentation of data. It is precisely with this third category that function points deal with. So function points do not measure non-functional requirements nor project requirements and constraints. These are out of the scope. Function points focus on measuring the size of the functional user requirements. Let's take a look at some examples of functional user requirements. Input forms. For example, adding a new contact in your phone is an example of a functional user requirement. Any type of report generated by an application. Business transactions, such as those found in data warehouse and business intelligence systems. Processing of data from sensors, like we find in aircrafts and cars. And any type of processing that involves mathematical and logical operations. These are all examples of functional user requirements that can be measured with function points. The next piece of the puzzle is understanding the components of function points. We start with the application we want to count. Any type of application, whether it is embedded, PC, mainframe, or cloud application, can be subject to function point analysis. The application boundary is an imaginary boundary that surrounds the application being counted. It helps to distinguish what data is internal and external to the application, as well as what data comes in and leaves the application. Internal data is the data owned and maintained by the application. This is the data that the application uses to satisfy a certain business objective. External data is data that the application uses as reference only. This data does not belong to the application. You can think of external data as read-only data that the application consults to perform a certain action. Inputs are transactions that bring information into the application, such as screens, forms, or data from external systems. Outputs are transactions that present information to the users or external systems, such as reports or messages. Outputs involve calculations, creation of additional data, or modification to internal data. Queries are transactions that present information to the users or external systems as well, but these do not include any calculations or modifications to internal data. Queries are basically retrieval of data for presentation. Notice that all of these transactions allow the application to interact with external users, which can be persons like you and me, but also systems such as other software applications or external hardware. One small caveat to this is that function points uses a slightly different vernacular for all these things. Internal data is actually called internal logical files or ILFs. External data is called external interface files or EIFs. Inputs are called external inputs or EIs. Outputs are called external outputs or EOs. And finally, queries are called external queries or EQs. In summary, these are all the components that are measured under function points. Notice that we look at data at rest, including internal data and external data. And we also look at data in motion, which is basically your external inputs, external outputs, and external queries. In function points, all of these components are actually called elementary processes. An elementary process is the smallest unit of activity that is meaningful to the user. This means that an elementary process is recognizable by the user and satisfies a user requirement. In addition, an elementary process constitutes a complete transaction, meaning that no more processing is required before or after the elementary process has been completed. An elementary process is also self-contained. This means that all necessary steps, such as validations, calculations, and modifications, are included within the elementary process. Finally, an elementary process leaves the application in a consistent state. This means that once the elementary process has been completed, the application is ready to perform the next action. In other words, the application is not hanging or stopped waiting for something else to happen. A good example of an elementary process is the registration of a customer into the CRM system. This process is meaningful to the user and satisfies a user requirement. It constitutes a complete transaction because all the information about the customer is entered into the system. It is self-contained because no additional steps are required to satisfy the requirement, neither before nor after the completion of the elementary process. And finally, it leaves the application in a consistent state as once the elementary process has been completed, the application stores the data and returns to the consistent state, waiting for the next action from the user. So, in essence, an application can be seen as a collection of elementary processes. These elementary processes are integrated together, forming what is called a software application. The application itself works like an engine to satisfy the business requirements. So in summary, there are two major categories of elementary processes. We have data files, which are essentially the data at rest. And then we have transactions or data in motion. Underneath data files, we can have internal logical files or ILFs and external interface files or EIFs. Underneath transactions, we have external inputs or EIs, external outputs or EOs, and external queries or EQs. Let's start with internal logical files or ILFs. An internal logical file is basically a group of data that is maintained by the application. The data is user recognizable, which means that the user knows and understands that this data exists. The data is also logically related, which means that it includes information about a single data entity. For example, if you have a database of customers, you don't mix that information with your purchases or orders. Those could be different data entities. Customers and purchases are separate data entities, and therefore they are separate logical files. A good example of an ILF is the contacts information inside your phone. This group of data is maintained by the application, is recognizable by the user, and is also logically related. So this is a good example of an internal logical file. The next type of data files are external interface files or EIFs. An external interface file is basically a group of data that is referenced by the application, basically a read-only file. An external interface file is also user recognizable and logically related. And finally, an external interface file is data that belongs to another application. So this data is maintained by an external application, which is not the application that we are counting. In this example, we have two applications. We have My Bank, which is the application being counted, and we have an exchange rates application, which maintains a database of exchange rates. So for My Bank, which is the application being counted, the exchange rates database is an example of an external interface file. Let's start with transactions now. The first type of transaction is an external input or EI. An EI is basically a transaction that brings data into the application. The data is stored within an ILF, or the data can also be control information. Control information is data that alters the behavior of the system or tells the system what to do under specific conditions. A good example of an EI is adding a contact in your smartphone. As you can see, this information is coming into the application. After you fill the form, the information crosses the boundary of the application and it is stored within the contacts ILF. So this is a good example of an external input or EI. An external output or EO is a transaction that presents data to the user. This implies that the data leaves the application being counted and is presented to the user. An external output includes calculations. This could be any type of mathematical or logical operations performed on the data. Finally, an external output can also create derived data. This is additional data that gets created as part of the transaction and is also presented to the user. An example of an EO is a report from your heart rate monitor. As you can see, the information in this report is leaving the application and it also includes calculations. Therefore, this is classified as an external output or EO. And last but not least, we have external queries. An external query is similar to an EO in the fact that they both present information to the user. However, the external query cannot perform any calculations nor create any derived data. An external query is basically pure retrieval of data for presentation. A good example of an EQ is a list of email contacts from your email application. As you can see, the information is leaving the application and it is being presented to the user. However, no calculations or derived data are involved. This is purely a retrieval and presentation of data to the user. So this classifies as an external query or EQ. Once all the elementary processes have been identified, The next step is to rate them based on complexity. Complexity ratings are required because not all the elementary processes are the same. As you can see, these two input forms involve different types and different amounts of input fields. Therefore, one of them is more complex and should be assigned a higher amount of function points. Let's now take a look at how we rate complexity for data files. Complexity for data files is determined by two attributes: the number of record element types, or RETs, and the number of data element types, or DETs. Record element types are basically logical subgroups of data within the data file, while data element types are unique data fields within that data file. Let's take a look at an example. This is a database that includes information about instructors and courses taught. As you can see, there are two logical subgroups of data: instructors data and courses data. We can therefore identify two logical subgroups, or two RETs. In addition, there are a total of 11 unique fields of data, so we identify 11 data element types, or DETs. With two RETs and 11 DETs, this data file classifies as low complexity. The complexity of a transaction is determined by two attributes: the number of file types referenced, or FTRs, and the number of data element types, or DETs. A file type reference is basically a data file that is written or referenced by the transaction. A data element type is a unique data field that crosses the boundary of the application during the execution of the transaction. Let's illustrate this with an example. The expense tracking application allows users to keep track of expenses using an internal file. A new expense can be saved into the system by completing the corresponding input form. When a new expense is saved, the application needs to retrieve the current exchange rates from an external data file. The primary intent of this transaction is to save an expense into the expenses data file. Therefore, this transaction classifies as an external input. One data file is being written and another data file is being referenced, so the transaction has a total of 2 FTRs. In addition, we have a total of 8 unique fields of information crossing the boundary of the application, so we have a total of 8 data element types. With 2 FTRs and 8 DETs, the transaction classifies as an average complexity external input. Once all the elementary processes have been classified based on their complexity, the next and final step is to produce the function point count. To achieve this, we're going to use the function point counting weights. As you can see, each transaction and each data file is assigned a different number of function points based on their complexity. For example, if your application involves a total of 5 average complexity EIs, that accounts to 20 function points. So all you have to do is fill in the blanks. For example, for this particular application, the total number of function points is 90. So this is the end result of your function point counting process. Now, let's see what we can do with this number. The most common use of function points is on effort and cost estimation. A parametric estimation tool such as SEER for software can be used to generate effort, cost, and duration estimates based on your function point count. Benchmarking allows organizations to assess their productivity by comparing against the industry data or their own historical data. Finally, function points can also be used for strategic decision making. For example, make versus buy analysis. An organization can use the function point count to determine if it is more beneficial to develop a specific solution in-house or get a commercial off-the-shelf product instead. So there you go. That was a quick introduction to function points. In summary, we learned what function points are. We also learned about the different components or elementary processes of function points. Finally, We saw what function points can do for your organization. I hope you enjoyed the video, and if you did so, please give us a like and please subscribe to our YouTube channel. This was Esteban Sanchez from Gallup. Thank you very much.